Welcome to the fourth video in the Python with AI series, where we'll learn how to automatically create documentation for our code, as well as create unit tests for it to validate that all of our code works by making use of AI. So in professional development, professional coders often write code that others can understand by making use of comments and docstrings, which we'll go over later. And the code professionals write also does not break when inputs change. So if the user inputs something different, the code should still work properly without any errors. So firstly, let's get started with automatically generating documentation for the code that we write. So one common way professionals do this is by using docstrings, which are multi-line comments with triple quotes surrounding them. And they come at the top of a Python function, and they outline the function's purpose, the reason why it exists, its inputs, what it takes in, and its output, or what the function returns. So here, as you can see, we have a function that generates a random math expression making use of the random module, or the random library that's built into Python. As you can see, it generates random numbers from 1 to 50 for each of the two numbers, and then it randomly picks an operator and then puts those numbers and the operator into a string representing the expression. And so you can see that when we run the code repeatedly here, it creates randomized math expressions. However, what if we wanted to explain this function in more detail so that others who look at the code in the future can understand exactly what it is? So in order to do that, we can generate a docstring to list the purpose of the function, the inputs of the function, and the outputs of the function. So in order to do that, we can use the and symbol in the chat, or the at symbol, and then focus on the random math expression function here, and then say, could you generate a docstring for this function listing the purpose of the function, its inputs, and its outputs. And then if we were to send it, then you can see if we paste it in, then it tells us the purpose of the function, generate a random arithmetic expression. And then this function has no input, so there's no need to create an inputs or argument section here, but it tells us it returns a string representing the expression, which is exactly what it does. So this just serves as an extra piece of documentation so that it's easier to understand the code that we've written. So now we have a new program here that acts as an interactive calculator, which takes in two numbers from the user and an operator, and then evaluates the expression based on the operator and the two numbers provided. So if we were to run the Python code, it'll ask us for the first number, let's say 5, and second number 3.14, and then we can do times, and you can see it returns, or rather it prints out 5 times 3.14, and these zeros and the 1 at the end are just because of floating point imprecision, just because it can't fully represent 15.7 exactly in binary. However, this imprecision isn't our main focus here because we want to add some comments throughout this Python file so that the reader knows exactly what's happening and why it's happening. So to generate some comments, we can ask the AI, could you generate some meaningful comments for this code that explain any complex logic? And then if we were to send it, and copy the code here, then you can see that it only creates a couple of comments. It doesn't fill the whole file with comments because that would overwhelm a person who's looking at our code. Instead, it just puts as many comments as required just to explain what the code is doing. It doesn't overload the reader. So it's just saying it in simple terms here. Prompt the user to enter two numbers and an operator, and then validate the operator input. This is for if we put something other than these 5 operators here. It'll ask us again. And then perform the arithmetic operation based on the operator. That's what all of these conditional statements are doing. Based on the operator, do a different operation on the numbers, and check for division by 0 if num2, the denominator in this case, is equal to 0. Then just print cannot divide by 0 to prevent any errors from happening. Next, let's go over how to generate unit tests to check if a function is versatile and flexible for any kind of input that's given. So here we've changed that calculator from earlier into a function so that we can just input 2 numbers and an operator and it'll return the result instead of printing it out. So we want to find a way to easily test this function with various different inputs to ensure that it works no matter what the user types in. So in order to do that, we can create unit tests for the calculate function, which basically just checks the function with various different inputs to see if it works properly. So here we've said at and then the calculate function here, the name of the function, and we're asking the AI to write a unit test file using Python's built-in unit test library, and it should include edge cases like dividing by 0 and negative numbers to make sure that it can truly accept any kind of input. And so now you can see that it's come up with some tests here, which we can run to make sure that the calculate function works properly. As you can see, it's importing the unit test library so that it can actually function, it can actually run these tests, and we can actually run them in the console to validate this function. So to actually run these tests, we create a new function called, or a new file called test.py, which will contain all of these tests. And I also modified the function so that it raises a 0 division error when the denominator is equal to 0. And so now we can run the tests by typing in python-n unit test test.py inside the terminal, and if we run the code, you can see a green OK appears. And so that shows that all the tests have worked, meaning we now know that our function's flexible with various different types of inputs because it passed all the tests. So if we were to make a small mistake somewhere, like replace the times here with plus by mistake, then if we run the test, you can see on line 15, this is a multiplication test. You can see the test to see if multiplication works fails. So this shows that these tests are actually running. It's not just saying okay all the time, and that they're actually protecting our code so that we can rewrite it and prevent any issues that we might find with the function later on. So as the challenge to conclude episode 4, try to create a well-documented function that's also free of any errors. So firstly, use tab completion to create any function of your choice. So this could be a factorial function or a tax calculator, for example, but you can do a different function as well. It just has to have enough complex logic to warrant a docstring, and 3 unit tests for it with 1 edge case, and you have to make sure that the unit tests all work successfully and a green OK is printed out afterwards. This concludes episode 4 of the Python with AI series. Thank you very much for watching. Make sure to like and subscribe if you enjoyed the video, and be on the lookout for episode 5 coming soon.